kick us off, do a quick intro, and then we'll go around. Hi, everyone. I'm Sara Stoudt. I'm an assistant professor of mathematics at Bucknell University, but I'm a statistician sitting in the math department. The things I'm sort of bringing to this conversation today, I just want to give some sort of prompts where my head's at with this sort of topic, is I teach undergraduates, right? And so when I'm thinking about like reproducibility, responsibility is sort of like, you either are good and you do it 100% or you're bad and you don't. And I'm wondering if there's a way that we could sort of build these sort of checkpoints that are more feasible and maybe less demoralizing as learners and also teachers of this. When we're teaching this alongside of some content, it would be nice to have some milestones like good enough for this level, good enough for this level. What is good enough? Just so that there's not sort of this like, yes, you're good, no, you're bad. Some other things I'm thinking about is that I personally really hate constraints when I'm doing the exploratory phase of a new project. I know I should be reproducible. I know I should be thinking about all those things, but I just want to like be creative for a second. And so I'm wondering if there are sort of guide rails that we could set ourselves up for success in that exploratory phase, that when we're ready to go to that more rigorous phase, we're ready for that. Are there sort of some nice on-ramps that don't feel too constraining at the beginning? And the last thing I want to just have us think about is the workflow is very data related, like our data pipelines, our analysis, but I'd also encourage us to think about how that workflow includes the communication aspect at the end. How do you have a responsible workflow of collaborative writing? How do you make that work when all of your collaborators have different experiences with different software, you're working for different journals that have their own weird constraints? That is part of the workflow too. And I'm wondering if it falls under the same sort of theory of what we want from that sort of responsible workflow, not forgetting that writing is a big part of what we do too. So I'll stop there. I'm looking forward to hearing from you all and learning from you all, and somebody else, please take it away.
My name is Valentin Danchev, and I'm a lecturer at the University of Essex, where I'm interested in computational social science and open science reproducibility. And I'm also data science educator, where I try to and strive to teach inclusive, accessible, reproducible data science students. And I've been thinking about those problems, how we can establish and in a way scaffold or design workflows that incorporate different principles of transparency, reproducibility, but even more going earlier in research design in terms of pre-registration, for example, and thinking about more about research design and how we select variables. And also on the other end of data analysis, in terms of data sharing, but also equity and fairness and documenting biases. So it goes in a way beyond as we typically will think about data analysis. And I think why I'm so excited about this panel and this cross-disciplinary panel discussion is that communities have established so many different tools and techniques to enable reproducibility and transparency, and also for software sustainability and reusability, and for code testing, and as well evaluating for harms and fairness. And it's so important now for those communities to talk together and to chat and to exchange ideas and in a way move forward the debate in a few different ways. One is what those responsible data science workflows should look like, how we should design them, what principles we should integrate them, and also what are the current gaps, challenges, what kind of problems still exist, but workflows do not address them. One way how I typically think about these workflows is as this extended cognition scaffolding, where it goes beyond data analysis, and we can organize those tools like notebooks and version control and environments in a way that foster responsible data science, foster reproducibility, foster transparency. And I know that many people in this panel have established some of those tools, techniques, concepts that bring this to bear on good research practices. And yeah, so I think it will be great to chat about those, and but also move beyond and see what would be, how this workforce could be inclusive as well, more collaborative, to bring different people together. I think the more workforce, responsible data science workforce are designed in a way that people can enter, that will be wonderful, and collaborate. That will be great. And also, what kind of incentives from a sociological perspective, what kind of incentives are not yet there? We've heard a lot about open science, and that some of the incentives in academia industry may not be aligned, and so that will be also an issue with the workforce. And finally, future-oriented, what will be the future workforce? Do we need one single workforce, which is probably unrealistic, or discipline-specific, or specific data analysis, or those that enable cooperation? And I think these are open questions that it will be great to explore and learn more from each other.
Yes, hi everyone. My name is Thibault Lestang. So I'm actually a research software engineer at the University of Oxford in the UK. And what that means is that I basically collaborate with researchers across the university. So not on a specific field, but very much across the university on different software projects. And these collaborations, they can be very varied. Basically, it goes from coaching researchers on software best practices, all the way to longer term software development, software maintenance, optimization, refactoring, etc., etc. Just a word about my background. I do have a short experience in research. I have a PhD in physics, and that experience is helping me every day as a research software engineer, because my job is all about communicating with researchers, understanding the research contexts, the limitations, the scientific questions, and the pressures sometimes that they face that apply to the software being written, and to work with them to make sure that the software that is supporting the research, or sometimes the software that is the output of the research, can be as high quality as possible, and therefore enabling high quality research. So I'm part of a relatively small group at Oxford. So we're not a separate company. We are a group within Oxford, and there are about 7 of us. And so our mission is really to provide the software engineering expertise that's really useful for researchers. And we do this in mainly 2 ways. The first one is, as I said, collaborating directly with researchers. So day to day, I would spend my day on 2 projects, for instance, sometimes in very different areas. So it's interesting to kind of compare and see how do biologists do things, and how do chemists do things, and physicists and psychologists. And the second aspect of my work is training. So we tend to do, as a group, and I tend to do as a research software engineer, a lot of training. We organize courses for researchers to learn how to, for instance, write tests, package their Python, package their R scripts, learn how to share their software, use build systems, etc., etc. And that's we can see that this is very useful. People actually enjoy this and think that's useful. But obviously, we're facing the incentive problem, and people go back to their research, and it's hard for them to actually spend the time and effort to learn on their own and then apply that. So that's something that you both mentioned, Sara and Valentin, and something that I would very much like to talk about. And lastly, I think the last aspect of my my role as a research software engineer, not especially at Oxford, but generally, is to advocate for better software practices in academic research. I don't mean by that I think researchers do a bad job. I don't think that's true. But I think that through more software training and more software advocacy, it could be perhaps more efficient, more sustainable, and also more enjoyable. So that sort of advocacy is something that I do locally at Oxford through local reproducibility initiatives, Reproducible Research Oxford, and also at a larger scale through the Software Sustainability Institute, which is a UK-based academic institute that promotes better software for better research. So yeah, I'd like just for more researchers to be aware that research software engineering exists, and that they can, collaborate with research software engineers to both learn more about software best practices and also benefit from software engineering expertise from people who also know research. I think that's the key point. And if you don't have research software engineers at your institution, then you could just ask your institution to say, well, we need software support. And this position exists. Look at the UK and Germany and in Norway, in the US, there are research software engineers, and it's working pretty well. So just don't hesitate to ask. It sounds easy, but just create RSC positions.
So hi everyone, I'm Kirstie Whitaker. I am the program director for the Tools, Practices and Systems research program at the Alan Turing Institute, which is the UK's National Institute for Data Science and Artificial Intelligence. I feel like that sentence is one of the longest that I ever say. The tools, so the Alan Turing Institute has multiple domains of research. So we have lots of applied areas in defense and security, urban analytics, health and medical sciences, data-centric engineering, data science for science, public policy. I'm probably forgetting one, which is very embarrassing. And you can think about the Tools, Practices and Systems program as being a cross-cutting program that's designed to sort of support the transfer of knowledge across each of those different areas. So for example, you might have really great geospatial knowledge inside of the urban analytics program, but there will also be climate scientists inside of the data science for science program, data science for science and the humanities. And so it's the Tools, Practices and Systems program's responsibility to make sure that folks in column A know about the folks in column B and have ways to share expertise. And then what we really want to do is exactly that activity, but on a global scale. And I think the open source ecosystem, so like the PyData ecosystem, but also, the R ecosystem, the Julia ecosystem, so many of these packages already exist. So much of this knowledge is already available. But one of the very, very hard parts is the discovery of that information. And so I'm going to build on points that I think all three of the panelists before me have said about the incentives. And so what we're actually trying to do is specifically hire people, either as community managers or as what we're calling research application managers. So these are inspired by the role of a product manager in a tech field and sort of pivoting those ideas to academia. And they will be people who connect up with users, with stakeholders, and make sure that we're not just building something that's kind of cool and interesting. We're actually building something that has a need that somebody else actually wants. And that the thing that we build, so I'm thinking of a software package, but it could also be an ethics framework. It could be a trained algorithm. But importantly, it has to have that user stakeholder engagement right from the beginning. And it could be something as basic as it doesn't install on my machine. There's no documentation to explain to me how to use it. Or it doesn't quite work for my specific use case. Can we help, as part of an open source ecosystem, can we help to sort of add in those features that would allow us to use it? And One of the other things that I wanted to sort of bring to this discussion, although I want to be very clear, I absolutely wholeheartedly agree with everything that every other panelist has said, but another dimension, I wanted to sort of bring up the concept of continuous integration. So we're at a PyData workshop, probably lots of people, but not necessarily everyone, will associate continuous integration as automated testing, probably on a remote computer somewhere. And if you run continuous integration on your GitHub repository, for example, then every time you make a change, your test suite is going to say, what was that change? Let me make sure that we're still getting the same answers from everything that we were expecting as we did before. And what I want to the reason I want to kind of reflect on that a little bit is I would love for us to consider the whole of the scientific life cycle as multiple continuous integration cycles rather than something that has a beginning and something that has an end. Because I think, that's a much better way of sort of incorporating feedback. It's a much faster way of bringing in contributors and sort of scaling out what's going on. It allows you to pivot. So one of the great things that is highly disincentivized at the moment, but very, very common, is that you have an idea, you work very hard on it, and then about 3/4 of the way through your, let's say, 2-year project, you realize that this is a problem that's already been solved, but you didn't know enough to sort of discover that GitHub repository or that tool that existed. And what do you do then? Do you just sort of like close your eyes and say, I was already in the middle of my 2-year project, so I need to keep going here and I have to publish something? And that sort of feeds this not invented here kind of bias that we see a lot in the way that people behave. And we also see this sort of focus on novelty and a kind of fragmenting of the tools that we're building rather than a cohesion across an ecosystem. And then the other thing that I want to sort of bring in on this continuous integration, this kind of continuous reflection and feedback, is that although the phrase isn't used in groups that are thinking about ethical responsibilities around the use of artificial intelligence, it is absolutely core to most of the recommendations that you should always be engaging with stakeholders, and you must always be reflecting as you go along. And so one of the things that I would really, really love to sort of see the data intensive research community to move towards is that we stop having access to sensitive data or building large computational models. We stop having kind of one ethical review process gate that has to be passed through or hurdled right at the beginning of the project or right at the end of the project, which has its own sort of huge amounts of problems if you've already invested a massive amount of time. But what if we set up multiple collaborative gates and we were really thoughtful about exactly what we can promise and importantly, what we cannot promise around biases in the data, around the representativeness of the data, around the fairness or how the algorithm is going to be deployed. And we don't try and make some great big promise right at the beginning. We make a sensible promise and we continue to iterate on that promise, thinking responsibly as we go. And I would love for us to sort of, that's just the thing that I wanted to bring to this discussion is how can we start to move from a linear engagement in research projects to that more either ecosystem level or that continuous dimension in time. And the person who's right next to me on the screen is Brandeis, so I'm going to hand to you.
All right, thank you, Kirstie. That was a great framing. Hello, everyone. My name is Brandeis Marshall, she, her, doctor. If you like that, adopt it. I lead Data at X. It is a data executive training firm. So we tend to work in the adult education space. So people who are currently in the workforce who are dealing with these problems like you are and trying to do our best in order to provide workshops, seminars, and pathways in order to do a little bit of what Kirstie was talking about, which is how to interject the the data practices and to look at it in 5 different lanes. And that happens to be in the collection phase, during the storage phase. The third happens to be analysis, which is the biggest one. Fourth is visualization, and fifth is storytelling or communication. So where at each point do we need to have more intentional talks about equity, and how do we then operationalize them? So when it comes to this topic of responsible data science workflows, I like to take a step back and really try to refocus the conversation, and where we work so well in is talking about who is the most vulnerable, where are the communities, and what's the impact to those communities first, and then reverse engineer everything else. So as someone that has spent my entire career in computer science and as an educator, there's a lot of intentionality when it comes to the mechanics of tech, right? How do you code? What step, which algorithm? What is the process? What is the linear process? And then what are the pain points? But the nature of the work is what tends to not be talked about too much within the tech spaces. And I'm trying to elevate that conversation, not only on my Twitter, but also in a book that I'm writing, in order to make sure that people are looking at who is the most vulnerable and trying to center their experience before even building the tech, because there are times in which tech doesn't need to be built. The tech part is complicating matters. So when it comes to responsibility, the responsibility aspect to me kind of falls under 3 avenues. One happens to be transparency. How transparent is the technology? And to the earlier point, I think several people made about open science, there is a lot of open software libraries and platforms that haven't really been vetted through an ethical or equitable lens. And so it does cause harm. And people are using it every day. So we need to have more transparency of existing proprietary and open source software. Secondly, there is accountability, and that is accountability from the big tech down to the small tech about what are their processes, where are they having conversations, and who is included in those conversations. Not only people in the community in which it will affect, especially the most vulnerable, but also making sure that tech teams don't just have people from STEMmy degrees, that there needs to be people from social sciences and humanities in these spaces, having these conversations and being active members as part of development teams. The days of tech people just talking to tech people needs to be over. OVER. And then, because it is frustrating, as a tech person, it's frustrating to say, hey, that tech is not needed. And then I get into arguments because someone just wants to create and write code and it's not necessary. Shout out to facial recognition in all spaces that don't need to happen. And then the last thing that I'll say is that the third area that I think we need to work on is really in tech policy. And that is a long-term plan. I know policy, especially government-wise, works slowly, but it is something that I believe is necessary in order to be another level of reinforcement to ensure that tech stays focused on being transparent and accountable. And I don't think that's going to happen with just a couple of misfits, or I like to call myself a rebel tech person, is not going to be helpful. We need to have a collective, concerted, intentional effort. So that's my thoughts. I'd love to have conversations about all of these things, especially prioritizing the most vulnerable in these spaces and who those most vulnerable are. With that said, I'll pop it over to Ben in order to give his introduction.
Thank you so much. And thanks to all of you for typing away furiously, taking notes on all interesting things you're all saying. This is fantastic. So I'm a professor of archaeology at the University of Washington here in Seattle on the unceded lands of the Duwamish. I'm also a senior fellow in the eScience Institute, which is our data science kind of community here at UW, and the director of a new interdisciplinary minor in data science, which after 1 year is now almost one of the largest minors on the campus for undergraduates. And one of the distinctive features of that that I want to share is we have a requirement that students not only take a class from a list of data skills classes, which are the traditional things that you probably imagine right away, visualization, statistics, machine learning databases, and so on, in which we prioritize open source tooling, although we allow classes that use closed source software, which are industry standards, but we prefer faculty to teach in Python and R and so on. We also require students to take a class from a list that we call data studies. So these are non-technical classes. They come out of the history department, American Indigenous Studies, anthropology department, where I'm in. And the kind of concept that unites those is that the courses are about an exploration of the ethics, implications, historical, political, philosophical, sociological, of the use of data-intensive methods and epistemologies. And so this is our sort of concept for giving students a solid opportunity to explore the responsibilities that come with data-intensive work and being a data scientist. So we don't imagine that we will create data science in this minor, that the minor will be a sort of stepping stone for them to go into maybe a master's program or something else that will allow them a career. But this data studies requirement is we feel a really unique part of our program that gives them an intensive opportunity to explore the responsibilities around data science. So currently we're growing this program. We're going to hire 3 new faculty over the next 2 years, and at least one, maybe more of those is going to be in the humanities. We just hired an English professor who started this year, who's doing data science in the humanities, on large corpora of poetry and pamphlets and ephemeral literature like that. And in our job interviews and our job ads and interview questions, we've been specifically putting wording in there that indicates that successful candidates will be those who have embraced values and practices that enhance the reproducibility and transparency of their work, and how they plan to teach that as well. So we're specifically kind of documenting our priority for this. And we've had, I think, some great responses amongst the candidates who perhaps have not been totally expecting that kind of question. And so I want to encourage all of you not to miss these kind of opportunities and these kind of soft spaces, maybe on the periphery of where we usually talk about the technical things about the reproducibility of the work, where we can communicate our values about transparency and reproducibility in these kind of things like job ads and interviews and stuff like that. So in my own teaching, I teach archaeology primarily at all levels, and a common theme throughout the empirical classes that I teach is the concept of the research compendium as a standard practice, from small weekly assignments, the smallest little bit of data analysis you can imagine, make one graph, right through to working with PhD students and their PhD dissertations. The research compendium is kind of this distinctive concept where we try to create as much as possible this self-contained archive of minimally, one code file, one data file, and that's kind of it. And toward the other end of the spectrum, it's a much, there's a Docker file and a binder configuration and so on that allows kind of push button reproducibility. And so in threading this concept of the research compendium, which we imagine as like a bundle of files we could deliver to another researcher, and they'll just be able to make sense of what's going on and reproduce or audit the work. We're coming into the sort of challenges that were outlined in the proposal for this session. It's like where are the conventions? Should we settle on one? And we're finding that at the smaller scale, obviously there are totally different conventions that make the most sense for ones that where we're thinking of a research compendium to accompany like a journal article, for example. And so we've been exploring those. I've been exploring my teaching and in publication as well. And I've also been engaged in my own research is prehistoric Paleolithic archaeology, mostly in Southeast Asia, but also a sort of side theme on meta science in my field, where every time I see a paper that's published with code in my field, I will take a good look and keep a list of it and try to see what kind of norms are emerging in terms of people struggling to make their work more transparent and reproducible. So rather than latching onto a convention that's emerged out there and just trying to dictate to that, I'm more interested in seeing like what is the least cost path that people are navigating through this challenge, and then communicate that more broadly and say, hey, like maybe post a tweet or something. Here's a cool paper someone else wrote that I don't know, but they've done an amazing job of getting their code and data so well organized. This is something that anyone could do. and hoping that that sort of more ground up sort of norm amplifying approach might be more productive than a more prescriptive approach. Let's see, still early days for that. So that's enough for me. I will pass to, is it Yacine Jernite? Is that the correct pronunciation? I think that's our last person on our list.
Yacine, yes, you're right.
Thanks, over to you.
Hi, hi everyone. It's great to be there with all of you. A little daunting to be the last one to give the presentation, but very, very impressed by everything I've been hearing, obviously. So I'm, I guess, here with kind of two hats. One is I'm a researcher at Hugging Face, which is a company that does open source software of both models and data, especially started with language processing, but now in many more domains. And in there, I'm working in a team that we're calling Data, Ethics, Models, and Society, to work a little bit more about the context for the technology and the context for the choices that we make. So that's one hat. And the other hat is at Big Science, we have been hosting and part of a project called Big Science, which is not necessarily the most imaginatively named, but I mean, size is of the essence, it really says what it's about. And which started inspired by that stochastic paradox paper that I'm hoping many people have read here about the limitations of having very small labs with very little diversity, making all of the decisions about training those language technologies that are going to affect many, many people. And taking another point of view, which is that as many people as possible should be working on those in the open. So we were very lucky to get a compute grant on the public infrastructure to train some of the model, which was already an answer to some of the criticisms there. And there's currently 700 of us from 56 countries working on many, many aspects. And within this enterprise, there are 5 different working groups that are specifically on data. So we have working groups on data tooling, working groups on data sourcing, what data gets included, on data governance, which is such a wide, big topic. On legal scholarship, we're lucky to have not only technical people, but also legal scholars, people with background in sociology. Thanks, for example, Valentin, who's been helping, and philosophy, and working group on privacy. So yeah, so there's lots going on there. At Hugging Face, we're more on the applied side and providing software that people are using, which means that there's a lot we need to think about what we're doing and what we're prioritizing and the norms that we're going to be setting. We've been doing a lot of work on, for example, normalizing model and dataset documentation, following recommendations from the data sheets and data statements papers. And at the same time, working on automatic tools for analyzing data, linking models to the data they're trained on. And we're an open source company. So more than making rules, we provide tools that we think are going to make it easier to implement more responsible practices and that are going to inform people about what they should be maybe thinking about. Right, so that's, and there's a continuous between that, which is applying the research and the technology that has been developed, and on the Big Science, more of driving the research and driving the research agenda from the ground up and from the source, from the choice of the data, from thinking about who has a say and should be involved. So I'm mostly working on the data governance aspect. And there we've been like taking this aspect of, I mean, echoing some of what especially Brandeis has said about being intentional at every step, which is that everything needs to be open and needs to be a choice that's made about, so we're talking about data, data is people, people have rights. How do every of our choices impact people's rights? Which rights are we talking about? So we're putting ourselves within a human rights framework, but also acknowledging the limitations of a human rights framework sometimes, and trying to take a self-critical approach beyond that, and implementing a data governance structure that is informed by all of that. And there I'm also going to echo some of what Ben was just saying about, which is that rather than writing these papers and these position papers about what other people should be doing that is corresponds to responsible AI, we're writing norms for ourselves and for the practice that we're having, and hoping that that way, first, we're informed by the hurdles that we find, and second, we can set a bit of an example and prove that, yes, you can actually do things in a way that's more self-critical and responsible.
Wonderful. Yeah, it's been great to hear so many different perspectives and yet commonalities and important dimensions that kind of cut across domains and expertise. I think it seems to me that where there is a common point is that we do need what Kirstie mentioned, this continuous integration across that goes integrates those technical data analysis to other dimensions, including reproducibility and transparency and open science, and then connecting to those ethical dimensions and also harms, what Brandeis Marshall mentioned. And so I think one question that we can explore a little bit more will be, what kind of challenges are in this continuous integration? So because when we see what kind of packages, what kind of tools we are very good at, for example, reproducibility and reproducible workflow. I think we now have well-established tools and for transparency and reproducibility, and the workflow would work across different open source domains, softwares, but how do we integrate this to the ethical dimensions? How do we actually evaluate harms and then actually bring back? And so also from a causal inference and design perspectives, people were saying, well, it reproduces well, but is it true? Is it actually this data analysis focusing on what we should study, which is actually from the from the start of the data analysis. And some of the ethical questions are also from the start, but also at the end in terms of harms and social impact. And so I think one dimension here could be to just examine what are the gaps, where this continuous integration is kind of hard to do it, and where should we work more to bring both communities and perspectives, not just tools, together, so that we have indeed this responsible data science workflow where reproducibility works well with ethics and kind of they merge together. And I totally agree that we're all seems to be doing that and thinking through that, but focusing more on the gaps will be probably helpful as the next steps.
Oh, I raised my hand. I wasn't sure how we were going to do that, but
Kirstie, yeah, please.
like we're in a class. So
I think rules are open, and we can actually all talk and chat and have a conversation, and we can actually redefine the rules because we have 2 hours. For some of us, it's very late in the evening, so it's definitely informal conversation. And actually, my wife has today birthday party, so it's for me definitely a wonderful day from many perspectives. So go ahead.
Okay, cool. I'm glad this is going to be pretty informal. So I think that when it comes to understanding the alignment between the two, the workflow and the ethical components, there is this tension that is kind of innate in how we learn the scientific method, right? Is that the scientific method is very sequential and linear, and that at the end of one stage will wrap up and it will begin a new stage, right? And so that means that you can't really go back. But what happens inside of the software development lifecycle is, of course, that there is a lot of feedback loops. And I think that notion needs to be brought forward a whole lot more, is that there is an evolution. And when you learn more, you do better. And unfortunately, at least in undergraduate curriculum in the United States, the software development lifecycle really doesn't hit the students and undergraduates' psyche until like toward the end of their college days. And so that means they spend, if they go to graduate school, they spend most of their graduate school time. And then if you go directly to industry, you spend your time in private or public or civic sector, then grappling with the fact that the scientific method is a great framework, but it doesn't translate very well practically. So ethically, we need to have this conversation, is that things evolve. That is part of science. And then we can actually now form the idea that having that feedback loop in every single cycle within the data workflow is a natural expectation, not something that you have to fight against. So that's something that I hit on quite a bit when I'm talking to adults, because they've been in the classroom learning a certain way, and then I'm telling them, well, you know that doesn't work, right? It's kind of like writing code by yourself. You're taught to do that in school, but when you get in the real world, you're typically coding with other people. You're looking at other people's code, commented or not. Sorry, pet peeve. I like commented code. And then you are playing off of someone else's understanding and style of how to code. That's not something that's taught in school, but when you get out into the real world, you therefore have to contend with that. So I think the ethics is the ethical layer is a layer that needs to have more involvement in the education system, but also be more upfront when it comes to the workflow about there's an evolution of how data is perceived, how it's manipulated, and then what the outcomes are. And even the language that we use, calling them answers when they're not answers, they're just outcomes. So it's this whole scientific method pins us to think that there is one solution, but it's not a solution, it's just an approach. So even the language that we use is setting us up to be very narrow-minded and closed, when actually we need to be more open so that we can hear the other voices and then integrate them more seamlessly and without friction.
Yeah, I mean, thank you. I mean, to bring up the discrepancy between the scientific method and software development, I see it pretty much every day. I'm working with researchers, and then a lot of them are working code, and then, oh my God, it's not doing what it's supposed to do, And I can feel this sense of failure, like it's a math problem that you're trying to solve, and there is one or it's either you get it right or you get it wrong. But in software, it's not like that. Software, you get it wrong all the time, and then it's part of software development to go through that. At first, frustration. There's fixing the software because the computer is telling you that, you got it wrong and you need to change something, or maybe you realize afterwards, but trying to get that message across that spending time on code and redoing things, going back to things is what it is, really. There's no escape from that. Then the problem is, when I work with PhD students and postdocs, there's a problem of time, because the time that they spend fixing the software or making it, refactoring this idea of you take software that already works and you make it more readable, most people understand the value of that from an ethical perspective, because you would actually want people to use your software and you want to contribute it to your community. But then where are the incentives? Because as postdocs and PhD students, there's a very high pressure to publish papers and produce the science, the plots that you want to put in your paper, because that's what's going to be cruel, bring food on the table. This is what's going to bring make your career advance. And so I see that although most people agree with these concepts, in practice is quite rarely done. And a lot of people, at least in research, a lot of people do code by themselves. There are a lot of people who code collaboratively, but there are also a lot of people who are writing their scripts on their laptops. And these scripts are rarely reviewed by other people, and often rewritten by the next PhD student.
I can jump in on this. I want to plus one very strongly Brandeis's position, and I think what's really interesting is it actually goes all the way back to like the way that you learn math, science, art, history, whatever language or literature you're engaging with, all the way from like the very sort of foundations of school. And you can think about like gender biases in sort of what does a scientist look like? What does a programmer look like? And one of the things that I think those ideas are really sort of, if you pull on the thread far enough back, you get all the way back to sort of, well, if there's a student who is 13 years old, let's say, and they like thinking about complex challenges that are knotty and thorny, and there isn't really a clear answer. And, you know, you can think, so history, I feel like, is that's like my sort of go-to one with that. You can kind of reflect on it and learn, but then how would you learn? What would you do differently? Things like that. And actually, what I think the conversation around data ethics is really making so obvious is those are the people that we need working in the data science teams. And one of the big worries that we have to sort of, as a society, undo, I suppose, is that those people will quite often define for themselves as being not a scientist, not a programmer, not whatever that category is. And so I do think there's this, I bring it up, I think, to sort of highlight that it really goes a long way back, and it goes down deep, sort of very many layers of biases that we have in our society. I think that's where, to some extent, if people are thinking about this and they're thinking about responsible research and innovation, and I think if anyone thinks that it's easy to do, then my position is that they have not spent enough time thinking about it, because actually, really, really, when you deeply dig into it, I give talks occasionally, and I had a slide on one of them where I said that for open science to succeed, we have to together dismantle the patriarchy, white supremacy, and capitalism. And that's, you know, if you wake up in the morning, you think, what do I got to do today? What's on my list? And you think, well, those are the three that I have to dismantle. That's a big piece of work. And I think actually recognizing how hard it is really, really important, because I think any of the sort of quote unquote easy solutions are, I think they give us a false sense of security. However, I sort of want to bring in Sara. I don't know if Sara, if you want to sort of jump on this, because I think one of the things that you said in your introduction, which I think is really, really important, is the all or nothingness that some of our conversations are around, and even the sort of badging of like ethical, not ethical. It doesn't really make sense, because it's a much more sort of multidimensional consideration, and it will be beneficial for whom? To whom does it distribute power? For whom does it consolidate power? And I don't know, Sara, if you want to sort of jump in on how you think about kind of stepping people up to completely dismantling a system, so that Thibault's position that you have to write papers, and papers are the things that are going to put food on your table, which I think is true right now, but I think it's a responsibility for all of us to dismantle that incentive, that it is no longer true. And I think we probably all agree on that front. But yeah, Sara, I don't know if you wanted to come in on that.
Yeah, sure. Thanks. I honestly, I have no wise answers for this, but I struggle with this myself. And then to teach students, it's like, right. Like how do we both espouse the value of like, we're heading towards this like perfect, like it checks all these boxes, and knowing that getting there, you have to fail to get there. And so is there a situation now, hearing you all, I'm thinking maybe if I have tried to myself be like, okay, what are checkpoints? Like good enough here, good enough here. And I struggle with that, but maybe it's a balance of like, what is good enough is related to the potential impact your work is going to have on others, right? So like, maybe that's the way to bring in students. It's like, okay, the stuff we're doing, as much as I want it to like impact the world, some students' project is maybe not has not the same opportunity to harm others as something else. So maybe there is this trade-off of like, okay, let's think about what are the impacts of what you're doing? What can we agree is a good enough practice here? And like, can we feel good about that? And like, oh, you're taking the next class, and like, let's up the ante of the responsibility aspect. Let's try to do a project that maybe has a bigger impact. And then we have to also up our standards of where we're at. And maybe that trade-off of like, where does this outcome go, can inform these sort of checkpoints I'm seeking of like, can you be 25% there and be happy at this level? Can we be 50% there? As sort of this way to not have people feel demoralized before they can even get there, right? I think that goes for researchers too. Like you said, if I only have so much time, can I pick one checkpoint that feels good for my situation? And that's a step. It's not perfect. I want to do better, but maybe that's a path forward. And I would love to, you all should tell me, what are these checkpoints I should be passing on to students? Because I just find it so hard myself. It's just like, I only have so much time to teach this thing. What is the thing I should teach? And then I get in this moral quandary of, am I teaching the right thing? Did I, shortchange whatever? But anyway, now I'm monologuing. Please, somebody save me.
I did want to jump on that a little bit on a couple of levels. One of them is that so students are not necessarily the best people to effect that change because they have less agency than many of the other practitioners. But they do have a choice of what they decide to work on and what they decide to focus on, which can make, and then that's a small chance that's going to change what topics are normalized or recognized, which can snowball into like shifting in the end, not by themselves, but as part of a pattern, what people think are acceptable research topics, for example. One of the other things that I wanted to mention there that I thought about was, so Dr. Marshall before talked about the need to also be on the tech policy side. And we do have kind of that like two-way relationship between technology practitioners and technology policy, where technology policy works with what's possible within technology, and at the same time, technology needs to comply to that. So I think the whole like data statements and model cards example that recently showed up in the EU AI policy is a very good example of that, of machine learning technology practitioners working on those possible tools, and then those being recognized as something that, yes, needs to be provided.
And just sorry.
Go ahead. Yeah, go ahead.
Oh, so just to add to some more things, if you're looking, Sarah, for some guardrails a little bit. So number one, I don't think there is a checklist. I don't think there is like a 25, 45, 85. I don't think that's ever going to exist because technology is going to evolve, and so is the software and the open source basis of what all the software is based on. So, but anywho. There is FAIR, F-A-I-R. So that's a scientific framework. I can't remember, out of the NIH, I believe, from a couple of years ago, that does provide some scaffolding in order for have some idea of how to make technology. I hate the word fair, so I'm trying not to use the word fair, but to be a little bit better when it comes to understanding and awareness of the issues that are involved. There's also CARE, C-A-R-E, and that is really centering the indigenous communities and how to make sure that they have data governance. So some of that framework is nice to share with a student population. Again, there's no checklist with all of this, but it does provide students with a awareness of what they need to be looking out for. And they're pretty short works and pretty digestible and good for conversation. The last type of resource I would suggest is Blind Spot AI. Blind Spot AI does have sort of these, it's kind of like the model cards, but it does go through a couple of different stages of what to look at during different phases of design. It's specific for artificial intelligence, but I think it could be extrapolated for other parts of the coding metaverse. Sorry, I use metaverse. Ooh, sorry about that, but y'all understand.
Great. I very much like this distinction between science where work is fragmented, and what Dr. Marshall mentioned, the work is fragmented, and then in software engineering where there is this evolution and development of a project. And I think most of the problems come when we think about this at the individual level, because we individually as scientists, we have to, and okay, that was 10 years ago. Now with open science, we much more discuss that publication papers, numbers of papers is not the most important criteria, but it's still a pressure, as Thibault mentioned, for many PhD students to actually deliver. But this is at the individual level. And I'm thinking here when communities are brought together, like for example, big science, and that Yacine mentioned, will actually have different teams that focus on different aspects, and they actually try to coordinate and work on those. So as individuals, we're fragmented, but probably we can create these social institutions that do the coordination, although every one of us is very limited. Same for Ben, that now he's trying to bring together this program of data science and to coordinate between humanities, data science, data analysis, and ethics. And for Brandeis as well in terms of communities, so she's involved in this, and I know Kirstie with the Turing way, trying to bring also communities together. And so I just want to hear more, what will be those broader social, sociological communities that could actually resolve and solve some of the problems of fragmentation of the scientific results and outputs, where we are limited with single papers and without building broader outputs, and how communities can actually save us if they could. Yacine, do you want to start with big science and how this is coordinated, and what kind of lessons are there for
yeah, of course. My internet is acting up, so I think I heard about 85% of what you just said right now. But I mean, I also obviously very much agree with the thrust. One of the things that has come up as a really important ingredient here is there's a very strong role for grassroots communities to play, which makes a lot of questions of legitimacy, right? What counts as a grassroots organization? Where do they get their legitimacy from? How do they report? Who's part of the effort and makes decisions?
Ben, do you want to?
Ben, do you want, yeah.
Oh, yes, thank you. I was going to say about the question of the types of communities that could be useful for tackling this problem of fragmentation. Just to raise the one that some of you may be familiar with, the community is called R Open Sci. This is amongst R users. And so they originally grew out of writing R packages for accessing APIs for data providers, and then became a sort of community that organized also conferences to mix people together from industry and academia. And they were very carefully, very selective in who they brought together these meetings, like novices and people who are very experienced and so on. And it's kind of grown into like a software quality control community as well, where they have an agreement with the Journal of Open Source Software that I'm sure many of you are familiar with, that kind of tries to occupy the space between software development and academic sort of credential for that labor. And the R Open Sci community have developed sort of a manual of how to write R packages that will be compliant with the Journal of Open Source Software and sort of achieve high standards of software engineering as well. So this kind of community, I think, is a good example of that, of a group that are helping to resolve some of these problems. They have converged on the R package as a sort of technical convention for doing their work, for accessing the APIs, and also as a kind of research unit as well that works well to treat an R package as a compendium. I'm not sure quite, and there's some disagreement about this in the R community, and I don't know what the equivalent things would be in the Python world, but they've certainly been very successful in creating a like constructive and satisfying sort of space and community for discussing and debating how to solve some of these challenges. So that would be something I would, I've enjoyed being part of and would recommend for the Python community as well. Yeah.
Yacine, do you want to continue your thoughts?
Yeah, I'm not sure exactly how much of what I was saying made it. Just wanted to insist on the ability to have people who do not have as much institutional access or technical creds or whatever to have a voice in those spaces, which is why I was really putting on the grassroots aspect, and also having like good community standards, a good code of conduct, like all of these things that actually have a strong impact in making sure that the right voices are heard and guiding those principles and standards.
Wonderful. And going back to just to big science. So the question is more or less, what do you gain when you have different teams working on those topics and they can coordinate, although none of them could actually solve. So some of them will work more on the technical, others more on the data ethics and representation or harms. And do you think that this could be a kind of a solution for the fragmentation problem that we discussed on the kind of, as individual researchers, we all face?
I mean, I think it very much does, but I'm also like preaching for kind of my own project there. So, but the thing that I'm really glad to see happen is that some of the problems will be surfaced by one group working on one paper that are more related to another part of the pipeline or the part of the research infrastructure. So someone working on modeling will find something that's wrong with the way that data is handled. Someone working on data will find something that's wrong with the way that contestation mechanisms are enabled, which is like from tooling to governance. One of the things also that has been important, I think, in that project, and it goes back to what other people have been talking about, is that we're talking about a project that is all in all a year and a half, which is still comparatively short, but is longer than what a lot of grad students have for a project, which importantly means that there is time to revisit decisions that have been made before we knew better without endangering the whole project. And I think both that transversal exchange between people with different specialties and the ability to have what people say directly impact how the rest of the project is going to be run is really, really important. And unfortunately, that's not quite something we get with like conference papers, right? Because like someone publishes a conference paper that puts those results somewhere, and everybody who has been like between the first 6 months before it was published and 3 months after that working on their own project doesn't really get those insights until it's maybe a little too late to ship the projects.
Yeah, just as an anecdote, I had a whole like Twitter rant about the way conferences do their review process, that it is not sustainable at this point. The whole reading, typing, and then submitting to this vacuum black box of people who then make a decision of whose papers get through and whose papers don't. So I think to a larger question is the whole notion of publishing papers and how it should be done to actually provide a model for more equitable work and transparency and accountability. So I think using Zooms would be a great way in order to have this conversation so that students who are in those short-term degree programs like master's degrees don't spend a year and a half doing something, that they do spend a shorter amount of time, can produce a paper, send it out, have a committee like this, right? A group of researchers who read the paper can provide that feedback, and then the person can make changes, adaptations, and get a paper published. But again, the whole system, it's a white supremacist system anyway, because it doesn't benefit anyone but the white guys that are able to have, paper mills. So they have 50 graduate students doing the work and their name gets slapped on it. So that whole system needs to be just burned up anyway, because it doesn't really help a whole lot, because there's papers that get through that really don't do any good, right? Papers that will change the way someone looks, skin tones of what people look like, change what someone is wearing. And it's always women who always get their faces changed It's always women who get their clothes removed, their faces transposed. It doesn't help tech's reputation anyway. So that's just my little rant. I can go on forever on that, but I will stop here. But the whole system just needs to go away. Like writing a paper doesn't mean anything, because if your paper is not impacting anybody, if it's not actually used, then what's the point of you writing it? Just because it's cited doesn't mean anything either. Because someone can cite your paper, you can cite your own paper, and it doesn't mean that it's actually being used or causing any type of benefit to anyone in society. So the whole holy grail of writing a paper is something that education systems need to dismantle, quite honestly, because it doesn't help at all. It really doesn't help. All it does is just regulate the same people to publish papers, and they have their friends help, and they help their friends publish papers. And as someone who has written a lot of papers that have been rejected, I can tell you a lot of my ideas have shown up other places and other people have gotten credit. So I think we need to really think through the importance of writing papers and really recenter the importance of what impact that paper is having. So data sheets that Yacine has mentioned multiple times it doesn't have any experiments in it. It's like 5 pages. And it has made a lot of impact. It needs to be in more CS curriculum. It hasn't gotten there yet, but it's on its way. That's an important paper. That's one to write. The stochastic parroting paper, Yacine mentioned, that's an important paper. Gender shades, that's an important paper. It's making impact, right? But these esoteric papers about scanning in the faces of your dead ancestors and seeing their faces move. Not so sure about that one. Or the fact that there are faces that are being made based upon the characteristics of other people's faces. Don't think that's an important technology that we need to have. So I'm gonna get off my soapbox before I really start saying some really radical stuff.
Thank you. Yep, Vera, please.
Hi, if I can just jump in the conversation, I would like to put 3 ideas over the table. First, I get you with the paper overload. I don't come from an academic background. I have done some research that people of the, I don't know how do you say in academic industry of the academic disciplines have found interesting and new knowledge. Yet for me, it was impossible to publish because I don't have the degrees. I don't have like the industry jargon. Even a good pharmaceutics friend told me that I should translate my plot into the pharmaceutic standard colors, which are not the standard by Wookie, which are the colors which are more optimized for neural perception. But anyway, so I think that the whole paper production pipeline is pretty rotten right now. I just want to introduce, I don't know if you already talked to 2 ideas. One is the Hippocratic jurament for data scientists. I don't know if you have heard about this. Sorry for the Spanglish. I have the title in Spanish, but the point in English. Which I like to resume to say that the role of the data scientist in the organization, instead of giving security and assurance to everybody else that we have this super model with it's going to be 99 feet, is all the contrary, to give doubt to the rest of the organization. Like, we have this model, but have you thinking minorities? We have this model in my current work. We have this tracker for people in order to understand if they have paid or not the transportation authority card. And my first response to the commercial guy was, okay, do you want something that will work in people with 2 legs and 2 arms? That's not all the people. That's just a big fraction, whatever. But you know your product is going to be attending that kind of people. And in general, about this Hippocratic jurament, I feel that the suggestion is to give us the role to give doubt to everybody else instead of give assurance. And the other stuff that I wanted to put over the table is this, like, I know it's pretty naive, but this 5-item list from, what's the name of Kationin, that algorithms should be auditable, transparent, appealable, improvable, and regulated, even if it's an internal regulation. Like in my home, we don't do biometrics. That's my home. And where I work, in my company, we have this policy that we don't do non-consensual biometrics. So when they sell some user cases that include that, we say, okay, no, that case is not gonna be there because there could be children, there could be mentally challenged people which are not in a position to give a consent. So you cannot simply do a biometric extraction of every face that go in the way. And to close, these ideas, I like to get this concept that ethics is a responsibility of everybody, not just the coder, not just the salesman, not just the academics, it's everybody. Please destroy my ideas. I want your feedback. I want to grow this.
I'll say I completely agree with everything you just said, Vera. I believe it's everyone's responsibility. I think the trouble we have is that not everyone is knowledgeable about the role in which they play. So they don't understand the level of their responsibility, and that gives them cause in order to not be part of the conversation. They say it's someone else's issue, right? It's kind of like the focus of a lot of data programs is on students. Like there's a big push for younger and younger students to understand data when adults don't understand what's going on. So you're trying to tell little kids how to be responsible about data, but adults aren't doing it. So the kids have no model. So you're then pushing the problem, pushing the can down the road 20 years. So everyone is responsible, but I think we're now at a point, an inflection point in which the education and not just being literate, but being engaged needs to happen by everybody at all levels of an organization, be it academic, government, civic, or public sector. That's my 2 cents.
I agree with that, and I agree Vera with your position as well. The thing that I wanted to highlight is the organization where you work, the fact that they have the courage to say no to opportunities. So getting data in that's been collated and it's been provided. I think that is one of the biggest hurdles that we all have to kind of grapple with. And it fits as well, it fits very strongly in the kind of continuous integration kind of idea as well. Because if you are going to continually, so on a somewhat regular basis, reflect on the work, reflect on whether your work is, your team's work, is achieving the purpose that it was designed for, minimizing the harm. And if you're going to do that really, then you have to also be able to stop that project at some point. And I think that is a problem. It's a huge problem in academia because of the funding models that we have, and because of the timelines along which we kind of expect people to show outputs. But I think it's not just an academia problem. So I think, you know, you could fold that in very strongly with the kind of like plonking PDF papers online behind a paywall in the year of our Lord 2021 is the ridiculous use of the internet ever. But I think it's so much more than that, because if you take it into like a startup sort of space, someone's gone around and sold this AI. They've you know, raised money, they're paying their staff. And if actually it turns out that the AI harms people, you know, facial recognition is obviously, you know, sort of canonical example, then where is the motivation for that organization to say, okay, our whole fundamental principle is no longer what we're going to align behind? And I think that's where, for me, so I said at the beginning that I work at the National Institute in the UK, the National Institute for Data Science and Artificial Intelligence. And I think this is where kind of courage needs to come from funders. I think it needs to come from government. And then I think we need to sort of lead by example and be transparent about the things that we stop doing. And I want to also just bring back a point that Sara raised right at the very beginning. So I agree that most academic papers have very, very little value, although I think they have a huge amount of work that have gone inside of them. But I think in terms of the impact that they make in the world, I think it's very small. But I did want to come back to a point that Sara made at the beginning. I think communicating is more important, just as important as it ever has been. We just need to think more carefully about the medium through which we're communicating. And so for me, that would be thinking about how do we incentivize documentation, right? Documentation for data, documentation for code, and documentation for kind of how they came together in an analysis, documentation around the limitations and the caveats. How do you sort of explain that? How do you explain for many audiences, policymakers, other technologists, people who are going to be affected by algorithms that have been developed? How do we really meaningfully explain what has been done and involve them in the decisions going forward? Those are all communication skills. They have huge impact in the world. And I would love it if we sort of expanded our definition of what it meant to communicate the work that we've done to include all of those. So it's not this, I had a meeting earlier today with a PhD student that I supervise, and she has multiple supervisors. And we were having a discussion about writing in the active voice or the passive voice. And she has some supervisors who are very, very keen on long sentences and the passive voice. So data was ingested and analyzed as such, blah, blah, rather than we analyzed data, we found this result. And I think those discussions are kind of, they're holding us back, and they're keeping us really sort of inside of a very narrow definition of what it means to communicate. And I would love to see more communication of things that didn't work, more sort of celebration of projects that were stopped. And one of the things that I really love about working in an open source ecosystem is that so long as you're working in quite a modular way, it sounds really hippy dippy, but like the journey is part of the deliverable. So if you are working in a public GitHub repository, everything exists, all of the learning is there. Even if you stop the specific project, and you might pivot it to something else. And so thinking, again, going back to that point about kind of thinking of the scientific life cycle as this very, very sort of iterative process, and really cheesily, really cheesily thinking about everything that you do along the way as being something valuable rather than the answer, as Brandeis was saying, the answer at the end that you then go away and tell people.
Yeah, I couldn't agree more with this. But I can't stop thinking of sort of to kind of take these ideas and see like, so why aren't we doing this? And trying to look at, what do people around me. The one thing I was thinking about is this demands to think on a long term, like the bit of my research, my contribution to research, even if the software I write, the research, no conclusion, or the conclusion is that there's no conclusion, I don't know, but this is going to benefit the field and the science on the longer term. But it's very hard to think on that long term when your contract is 6 months or a year long. And so I think that you look at institutions where contracts are longer or sometimes permanent, then it changes everything, because then there's a lot more room, a lot less pressure to take on that work and to think of a longer term. But then in most of the institutions that I'm familiar with, as postdocs, most postdocs are employed for a year or two, maybe 3. And that limits your vision as an individual, because it forces you to think as an individual. So how do we cope with that? And I mean, obviously now it's at the level of an institution. I just had that in mind. Like, how can we implement these ideas when most of the workforce who's producing research, the means of research, are actually employed quite precariously.
I would like to just jump in here and encourage anyone who's in the UK to vote, to join their union and vote in the upcoming ballot to take strike action for exactly this precarity problem. It's precarity across so many different levels, but the postdocs are particularly affected. And I completely agree. And I think it's also important to recognize that it's not the postdocs' problem to fix. And that's something that's really important, that it's not the people who have the least power in the system, even though they're at the coalface, they're at the front line. So they could implement, reproducible notebooks, they could write better documentation, they could do all these things. But it's really important to recognize that it should not be their responsibility for exactly the reason that Thibault said. And then, sorry, the other thing I want to just highlight, because we have a large research software engineering team at the Turing Institute, and I want to highlight just how radical the concept of a research software engineer. So Thibault was talking about it earlier, and that's your job, and you described it really beautifully. But most research software engineers are designed to be flexible. They're designed to be able to work across lots of different projects, and they should be, although not every team across the UK is, they should be on permanent contracts. And so suddenly you now have very talented, expert people who can collaborate broadly, who have the technical expertise, whose jobs are not determined by the number of citations on these PDF papers that are behind firewalls. Their jobs are determined by whether they help others to deliver the really high quality work. And the more permanent positions we can get across all of data science, the more likely we will start to work on a longer time scale. And I think it's unbelievably important to start investing in that.
Wonderful. Probably we could discuss some of the questions that we have in the chat. So let's start with the one about reproducibility and thoughts on where the main push for reproducibility should be coming from education, from journals. And I would like to extend this a little bit and think about the different areas that we're interested in, including ethics and representativeness of data. And so those other dimensions, what is their different push actually, because I think they're slightly different. As we know, for example, from some areas in psychology, it's been some evidence of reproducibility crisis, and then more or less internal push from the scientific community to address those issues. For some of the other topics that we discuss is probably a different push, and so yeah, would love to have your thoughts.
So one idea on that topic that is absolutely not from me, I need to credit to Deborah G, was that one of the things about being transparent is that it exposes you to being critiqued. And the question then is, then what, right? And one field that has been doing good work of that is mechanisms for reporting security flows in software, where like you are incentivized and required to report those flows in a way where you are giving an opportunity to fix them, as opposed to being punished for reporting them. Obviously, again, like not my idea, but that's something that we can definitely talk about more in how we implement those processes.
Great, yeah. I think this also goes back to what Vera mentions, the first point that we should focus more on doubt instead of assurance, and instead of certainty, and to focus on uncertainty and not being penalized for that, but rather being acknowledged that we understand the bounds and the levels of uncertainty that any particular result or estimate will give, and to acknowledge that. I think here, going back to what are the pushes for transparency and reproducibility, is that scientific findings typically are, especially during COVID, are communicated and discussed broadly with the broader community. And so one dimension is whether this exaggeration and spin is among the scientific community or from papers to the broader audience. And I think there were examples of both of those, but there are some initiatives that at least acknowledge and argue for giving more voice to uncertainty and limitations of research. But I agree that in terms of reproducibility and data sharing in the scientific community, there are still more penalties rather than those constructive tools for constructive criticism. That's actually continuous integration and update rather than binary decisions, whether that's good or bad.
And I wanted to chime in to say reproducibility, I think, is a conversation and an action to be taken at all the stages. So it's not just one or the other. So education, you do the toy version of it, but then inside of organizations, you do like the grown-up version, right? Where you do have critiques, you do have penalties, you do have constructive criticism that then you're folding in. So I don't think it's just in one spot for reproducibility. But at the end of this question, talking about journals and reviewers, I think that there is a layer that we don't talk about, which is the labor of reviewing. And that labor is free labor. And that free labor is of people with a whole lot of degrees and not a whole lot of time. So I think a structure in which the reviewing process in general is not reliant on free labor, because it is a lot to review a paper and to review a journal, to go through the steps. I have not been part of a review process on a journal or a conference paper where I had to look at reproducibility, like actually running code and things like that. So I don't know how that process would be done and what those steps are. Would be curious to know if anyone else on the panel has any idea about that. But I think that there is a separate question here about the free labor of reviewing. And so if you are doing something for free, you have 10 of these things to do, there's only so much time you can dedicate to doing a a thoughtful, complete, full, comprehensive review of the work in order to bring out the critiques and to also not be in more the penalty box, because your rate of bias in how you see a paper depends on which order of the paper you're reading and how many papers you've had to read over how many days, just being quite honest. So, you know, I think there's just other things about reproducibility here when it comes to review that we have to talk through as a scientific community if we're really going to address some of these issues.
On the question of peer review, I think that's a fascinating element of the process where we have this great challenge of the tremendous burden that potentially gets much higher if we have these demands about reproducibility and openness. There's so many more things to look at and run the code or not or whatever. But I also think the other side of that challenge is that it's also a wonderful opportunity to just move the needle a little bit. And in the course of doing the peer review, say, well, you know, I can't really do a proper review of this paper because I can't see the data and code that generated the figures. And either stop the review right there and then give the editor this kind of issue of like, well, do I then raise the expectations for reviews generally and make this author submit this stuff to review? Or continue on with the review. For example, I will face this challenge, you know, if it's a junior scholar then whose work I really support, I will say, well, this would be better if it had the code and data available, but here's some other thoughts anyway, and, you know, good luck with the paper. If it's a senior scholar or peer, I would say, this is it, you know, show the code and the data. I'm not doing any more review for you until that comes through. And I think that is a useful thing that is cheap for us in terms of time and effort. Just declaring those values around peer review, which helps to communicate to editors who are usually the kind of people that we need to wait to retire or die before there's going to be change in that part of the way that journalists run. But these are values that are shifting and emerging in sort of professional communications. And I really like the way Kirstie talked about communication as kind of a central part of the challenge of improving reproducibility, and the peer review process is just one little channel we have to communicate in a really profound way, because editors desperately need the peer reviews, and reviewers will kind of walk over broken glass to satisfy the requirements of reviewers in many cases. So I think this is an opportunity that we should be, like, on one hand, to be sensitive to the burden that it's going to create, but also to exploit in a way that will further the sort of sustainability of transparent practices in the discipline. So really interesting avenue of practice that I think is underutilized by people who value these things. Yeah, thanks.
So another topic I'd like to touch on here that actually goes back to some of what Ben was talking about in his introduction about designing a data science program that has other epistemic processes and other sources of knowledge. Is the role that we give to investigative journalism in who is critiquing the work that we do and where they're coming from. Because, for example, I've been working a bit on the technology of automatic content moderation, and that's who's pointing the limitations, often more than ourselves as technology participants. I'm coming from an NLP, but I'm sure that there's other experiences that other people have had in other fields. Or going back to the gender shade, which was more of an integrated effort between researchers, public presentation, and journalism.
If I can jump on the reproducibility issue, I think that the knowledge consumers we're going to moderate, and in 50 or 100 years, you are not going to believe anything that is not fully reproducible, but also like the second step, because it's going to be fake news. If you cannot reproduce it, it's just fake news. But one very important issue in reproducibility is that you can, I come from the DevOps world. So when I got into data science, I was in shock in the crisis of reproducibility of knowledge, or of official knowledge. And I'm very kind to the DBC tools and CI tools that allow you to just do a git clone and DBC repro results data steps, something like that. one of my best students, which is also doing a master. Her master professor said that was the most easy project in his life to just run it, because the CI tools allow you to do that. But that only checks that the code and the data version that was used for the code do something, but it's not gonna be really, really validated until somebody else changes something and say, okay, your method is cool, but what happens if I use exactly your same code for the method in my data set? Or maybe your 3 initial steps of data set are cool and the 7 last are cool, but I want to change something in the middle. And that is the research or knowledge, if you just publicize not in papers, that is giving trust to the original research, that what you did is not only reproducible in the sense of the code that can run, but also each step is scientifically sound. So I can change just a part and get something coherent. I don't know if you follow me.
I think I've seen some work on this, like it's called the multiverse, where it's essentially like your paper, but you allow your people, like somebody can interact with your paper and all the decisions you make, try something else. So like I did a t-test here. What if I had done, you know, a fancier t-test that accounted for this thing? And it sort of like lays out this framework for sensitivity analysis to all your choices. And then if your paper still reads the same, we're like happy. That seems good. That's like, I guess, replicable if we're making those annoying distinctions between reproducible and replicable. I'll try to find the link and put in the chat, but the idea that yes, if you make it easy for people to change little things in your work and still get the same answer, that's sort of like even better. That's like maybe reproducibility plus, and like tools for that. I think I only know of this one tool I'm thinking of, but that to me sounds interesting. Make it easier not to just click a button and reproduce your results in this situation, but let's be easily toggle with things I might not agree with. Like, oh, I don't buy this that you took out these outliers. What if I put them back in? Could I quickly see what happens? Keyword quickly there, I guess. Do any of you have better tools for that? Because I'm nosy and would love to know.
I'm sorry, I don't have the tool. Sorry. But maybe it ties to the idea of, you know, if you publish or if you contribute something, do it in small chunks instead of, because if I, you know, when in my PhD, I just didn't publish a lot because I published one massive paper, and that was just a big mistake because, you know, it's completely unreproducible, to be honest, and because it's, you know, from start to finish, because you really wanted to, you know, view the full picture and publish the full thing, because you know, and then this idea of, you know, we don't want people to just start doing what we're doing, you know, it's kind of like my research, my work, and then I could feel this kind of like atmosphere around. But maybe if you change that approach and then you say, well, I'm going to publish, or I'm going to share, or the past few months of work, this little chunk, and then somehow when you feel like, okay, now I think I finished my project, then you have a series of contributions that you can tie together. And so now if you want to change a piece, it's clear, or you go to that reference, that paper, or that contribution to that software package. So instead of maybe a tool, there are probably tools that allow you to do that maybe in a more granular level. I was listening to a Python podcast recently, and they were talking about it's not a pipeline manager, it is something close to it. It's called Kedro, and then they were explaining how it's something that allows you to kind of wrap functionality into nodes, and then you build your pipeline from different nodes. But that's much on a more technical level, but maybe at a higher level, starting to value smaller, more frequent contributions.
I just want to jump in here. I totally agree with all of the points. I want to bring in another dimension, which is a lot of our conversation around reproducibility is assuming that everyone has access to the data. And sensitive data, I think it was Yacine who was saying, like, data is about people. There are people represented inside of that, and they may not have chosen to have given, well, if you're, for example, if you're scraping social media, none of those people actually gave consent for their words to be used as part of a research project. In other cases, I do some work on electronic health records, and people may be willing to have their work be used for a certain purpose, have their health records be used for a certain purpose, but not necessarily for everyone. So a big example is that there's work that's been done by the Wellcome Trust, talking to lots of patients and members of the public, that in general, patients who are represented in the health record system in the UK are pretty happy for the work to be used by researchers. They're also quite happy, which some people will find surprising, for their data to be used by pharmaceutical companies. The organizations that they really don't want to have access to the data are insurance companies. And, once you say it that way, you're like, yeah, of course. The pharmaceutical industry could come up with something like, I don't know, a COVID vaccine that would really change the world and make life an awful lot better. Academic research, I don't know quite how much help. Well, it does. There are papers that do have value. They tend not to cause a huge amount of harm. But I think insurance companies really do have a huge amount of sort of potential to cause harm. And so the point that I want to raise is it's maybe a little too strong, but data that is really valuable, and I don't mean like you can sell it for a lot of money. I mean that it has a lot of information inside of it that our algorithms would be able to kind of elevate out to give us meaningful insights into the world. I would argue that most of that data should not be made openly available. So health record data, financial record data, even personal sort of text. I think we have to be much, much more thoughtful about kind of why people have made that data available and for what purpose. And so that has been my biggest barrier with reproducibility. It's actually the data governance. It's actually getting people access to the data. And we have two veins of work inside of my program at the Turing Institute. One is thinking about reproducible and redeployable, reusable, extendable, scalable, all the fun words, trusted research environments. So actually being able to spin up, including all of the governance procedures, identical or customized to be the sort of as needed trusted research environments. So you have the hard shell that sits outside. You are very focused on, you're very careful about who has access to the data inside, but what happens inside it can be the same as in another trusted research environment. So you build some interoperability between those, and that would allow us to start to think about things like federated learning across a secure research environment network. And then we also have an area of focus on synthetic data. And there's really interesting aspects around synthetic data for sort of, some people will think about how close you can get to the real data. And there's a sort of catch-22 that you get there. If the closer you get to the real data, the more likely you are to leak personal information from the real data. So you get into this kind of, where do we draw the line? And we have a research project at the Institute that's led by Martin O'Reilly, who is literally trying to sort of come up with determinants for where you do draw that line and under what circumstances. But what I'm really interested in with synthetic data is actually not how do you get synthetic data that is as close as possible to the real data. But how do you get synthetic data that allows you to work in a very collaborative space, something very much more akin to working openly so that people can see the data, they can interrogate the code, they can change one of the decisions along the way and see what effect it makes. But then you still take your pipeline once it works and you map it to inside of your trusted research environment, and then you run it on the real one. And then you have to do some sort of comparison between those two things. But that allows many, many more people to get started, to interrogate the algorithm, to really understand what's going on without the, I'm going to use the word burden, but I think it's really important to recognize that the responsibilities, the legal responsibilities we have around protecting access to data, they're real. They're not sort of for no purpose. They're there to protect the rights of the people who are represented in the data sets. But if we can start to sort of modularize how and why people are working on the real data, if you want to have the real answers that sort of, come out, or some of the development work that could be done on something that looks like synthetic data, I think that's a really powerful step forwards for us that would allow us to sort of extend some of the purposes of reproducibility, extendability, reusability, without necessarily having to explode the number of people who can actually see individual rows of people's financial records or people's health data, for example.
Wonderful. Yeah, I think that's a, go ahead. Yeah.
I was just going to say that the reproducibility issue and how that dovetails with personal data privacy is always a very interesting conversation because of the nature of what is considered sensitive and what does sensitively mean to different people, right? Because certain people might think that their gender identity is sensitive and other people don't think their gender identity is sensitive. Some people think their disability status or veteran status is something that is sensitive and other people don't. So understanding what is the personal data privacy conversation is a very interesting one. The other comment that I had was the kind of shadow boxing with synthetic data versus real data is very much a symbolism of just the basic issues when it comes to sampling biases. So it's entering to a stage of, do we have the right sampling of the population that is in the synthetic data that is really something that's representative of the real data. So it's a problem that we've seen before within the scientific community, and therefore we have an idea of the challenges. What are the challenges that are still open and the challenges that have been semi-resolved as far as approximating things. So as someone that is marginalized in several different ways in data, because I'm counted like 3 times in data, I think it's important in order to have baseline conversations about how people with different identities are really represented inside of any data set, be it synthetic or real. Because I'm counted, as I said, like 3 times, a Black woman, an American. And so my everything that's around my data, it's pretty easy to know who I am. It's pretty easy to identify me. There's not too many Black women in computer science with PhDs. There's like 100 in at least the United States. So it's not hard. My name is pretty unique. There's 2 people named with my name in the United States. So, so the characteristics of people in the data and how you model that synthetically versus how do you model, how is that represented in real data becomes a whole nother question, as I said, that's very, very much akin to sampling biases that do, again, harm people that are unique and are on the outliers, because all of scientific method is going toward the majority, and the majority don't look like me.
Absolutely.
I'm so sorry to interrupt this awesome discussion. We could stay here for more 3 hours, but we have 5 minutes left. Just want to remind you on that
Absolutely, yeah. Thank you. Probably we have just time for final remarks. I wanted to bring one of the questions if we want to discuss, because we chatted about different solutions, some of them related to community, other related more to communication. I think one of the questions brings the role of regulation, and so how we compare data science in general to medical practice, and should we have actually association to accredited data science practitioners? So this is a question by Brian, and I think that's if you have any thoughts about the role of regulation and about data science practices, and if you have any thoughts of that.
I want to bring in.
Oh, sorry, go ahead.
No, it's fine. I was going to say I want to bring in Brandeis because someone else earlier commented about some principles that teams could align to. And Brandeis, you said that it was a performative gesture. And I want to sort of, I'm really curious to hear you expand on that a little bit more. I think there's a possible counter to saying that it's a performative gesture, which is that every journey is made up of lots and lots of little steps. So potentially if we can get even just a few more people to think a little bit more carefully about sort of what their responsibilities are, that could be a strength. But I'm very open to you saying that that's an overly naive and that we are just sort of patting ourselves on the back by signing a list of principles that can't actually be enforced in any way. So maybe I'm preempting your argument a little bit there, but I wanted to just open that up for you.
Oh, that's funny. So yeah, it's just patting yourself on the back because there's no call to actions. And so with no actions, there's just chaos and nothing, and just stalls. It stalls any type of behavioral change. And without behavioral change, nothing is going to happen. So yay for signing, but there's nothing being done that's actually making any impact. That's what I have to say about that. When it comes to the question that you pose, Valentin, I think that certifications come along with it a lot of social economic understandings. And that means that there is money in this and who is going to be leading the charge. If it's not a Black or Brown led organization leading the certification charge, then I don't want anything to do with it. And it shouldn't be anything other than Black or Brown led, period, the end. That's how I feel about certifications. Because any certification by anybody else is just a money grab. So, and since they won't give money to Black people or to brown people, then therefore the certifications won't happen. So that's the end of that conversation. That's how I feel about that.
Okay, final remarks, thoughts.
So I did have one thought about, that goes to what both Kirstie and Brandeis have talked about. A lot of the conversation that we have about what we should do are about what we should do, still assuming that we should be making those decisions and making those choices and deciding what the principles are. Whereas in a lot of cases, a lot of what we can do is build power out. So like agree on who else should be making those decisions. So sometimes it's just, so we talked a lot about transparency. Transparency is one of the ways we do that, right? Is by like giving away our privilege to just what we do in our corner and opening ourselves to having other people tell us that we're wrong. Another thing is having opt-out mechanisms in technology, which means that we don't keep our captive audience that needs to pay for our services, but we give them the option to, without a penalty, decide not to participate. And we also have then a feedback mechanism of people actually like not participating if we're doing things wrong. So yeah, always wanted to mention that at some point in that conversation.
Wonderful.
Thank you so much for being here with us. We really appreciate all the discussion. Thank you for being at PyData Global. Thank you so much.
Thank you.